Got it.
So as I say every week, I didn't do anything this week, so um, I don't have anything major to announce. And Terry's on today, and he's got something to show as well. Let's turn it over to Terry.
Well, first is the mistake that I made and kind of damaged a solderless breadboard. But so as part of that, I then moved it to a new, bigger breadboard, and I've got it's a itsy bitsy. I've got a FTDI board, so I can communicate via RS-232, simulating what's going to be the Raspberry Pi that'll be on my robot. So I'm kind of simulating what the messages that are going to be going back and forth. Just written a little VBNet form so I can kind of send messages and get the ticks and power and PWM and all of those messages back. But when I do a set power, or when I run a auto test that I created, which just basically increments every second the power up to 100 on one wheel, then down to negative 100%, then it back up to 0, then it goes to the next motor. Haven't had the problem with the right motor, but periodically when I've got it on the left, it'll just stop. It reboots and no error message that I can see. I do have the serial monitor set up, but sometimes it then kind of must send some message that stops the serial monitor from running until I shut down the Arduino IDE. So not sure what's going on. I don't have a scope, so I can't watch the power line to see if it fluctuates or anything, but any ideas?
The fact that you burn up your breadboard, that seems fairly extreme there. So did you just have 5 volts on one side that was running the encoders and 3.3 on the other side that was running the microcontroller? Is all that's hooked up there, or did you have any kind of like motor power running through the thing?
No motor power is running through it. I have my 4 signal wires and a ground going to the Cytron board. But it's on a completely separate battery for the motors versus the electronics.
So
but they do have the shared ground.
So since you have the 2 batteries there, check to see, because it could be that all your power for your motor is going through that ground lead back to your breadboard, your microcontroller. So maybe look at that a little harder. I can't think with there's probably some obvious way. Once you get it set up, here's the motor driver and the motor, or you got the microcontroller and its stuff, and then at one point, then you should hook the grounds together. And I don't know, because the thing is, you got them hooked together and you got a loose connection, then all the current's going to go back through your ground lead, going back to your microcontroller and coming out that way. So that I'm just trying to think why that board really got so hot.
I'm not even worried about that board problem was 6 weeks ago. And since I moved it to the new board and rewired it basically from scratch, I've not had any heat problems. So I'm kind of ignoring that at this point.
But your other, like the rebooting problem, is still there, though?
I wasn't having the rebooting problem on the old board. And I think this Cytron board, the grounds are
they are tied together on that. The motor ground and the logic ground is tied together.
Okay.
Most things you buy, it is. So it's something worth checking, just so you know. And then if you need to get around that, you're gonna have to go to like opto isolation or something if you don't want don't want that connected, but
Okay.
and just a reminder, don't forget about your computer upstairs. So whenever you need to run off, you can do that.
I need to run off.
Okay.
So I'll be right back.
So Al, anything?
Well, for me, haven't made any more progress on my path planning. What I did do is spend some time on my 12 volt or making a 12 volt battery out of some lithium 4-volt cells, 4.2 volt cells. These are SPIM 00, I'm sorry, SPIM 08 HP batteries. There's the right there. Did that come through?
If you hold it still, it will.
Are you complaining?
I just giving you a suggestion there.
So anyway,
you can hold it there all day, but you wiggle it, keep wiggling just a little bit. It'll keep defocusing. So that's why it'd be handy if you had something you could lay it on and then just something prop it up against to put stuff on. But anyway,
there's these I can get for about $6 a piece, $6 or $7 a piece, and if I take 4 of them, I can get up to 16 volts, although I don't need 16 volts. I just run them less, run them at like 3.6 volts and I get 13 volts or 14 volts. I think I charge them at 14.3 volts. But connecting them is always a bit of a pain because most of these come out of electric buses. And when I bought these, they weren't selling the 3/8 inch steel rod that goes between them with a nice threaded hole in it. So I ended up getting these guys, which are obviously clamps, and then crimping them together. And so I've got 2 of them put together, and I need to put the other 2 together and then connect this battery management system. And on my other tractor, it lets you monitor how many amps are pulled, and I actually have 100 amp BMS on it. But when I monitor the actual amps drawn, when it 150, I think I've seen 180. So anyway, I went ahead and got the next size bigger, the 150 amp, and this would have some that's continuous, and it would have some, I forgot the spec on what it's, the peak on it. What's interesting on this is I saw it'll take, you might not be able to read that, but it's got UART and CAN input. These happen to be temperature sensors because below freezing, this thing shuts off to protect the lithium batteries because they don't like cold weather. So anyway, putting all that together is my next chore, along with finishing my path planning that I talked about last week. So other than yard work, that's what I've been up to.
So back to Terry's gadget. Have you ever checked that board from Adafruit and checked to see if the pins are 5-volt tolerant on the, even if it's a 3.3 volt processor? Some of the processors will say the pins are 5-volt tolerant, so you can hook 5-volt logic directly up to them and not hurt anything.
It says they are not.
Okay.
The itsy bitsy.
Did you hold up that your Protoboard again so you can see which wires were getting so hot on that?
It was I believe the power. It was either power or ground.
How did it get on both sides though?
That would have been a question if I felt like delving into it.
But I
But
mean,
it
what was
was
hooked up on the, I mean, there's a left and right channel there. What was
right.
hooked up on?
That was this was the 5-volt bus. This was the 3.3 bus. I was driving the 3.3 from the voltage regulator on the itsy bitsy board. You can put 5-volt in, and it's got then a 3.3 out.
That sure is a lot of damage. Does the board still work? Can you do a blink on it?
Yeah, I can still use the board, and the level translator seems to be working fine. And it was the level translator, which is what was in those positions.
I was just going to share the one. Let's see. That's the one that I bought.
That looks exact. Well, it's not quite. Mine has a little bit of a piece hanging over from the where the pins are. So it's slightly different.
Like I said, I was never able to actually get it to work. I had a 3DR radios that were 5-volt. I assumed they were 5-volt. Well, I knew they took 5-volt in, but anyway, I never could get those to run over a level shifter.
And I think that particular level shifter, you go look at SparkFun. The SparkFun is the first place I saw that type of board, I think. So I don't know if they just, since SparkFun said their stuff is open source and everybody makes them and resells everything. So if you need more documentation, the SparkFun website's a good place to look for those kind of things. And I personally just use logic chips to do the translation instead of those cute little MOSFET things that I think they were probably originally made for I2C, and I don't know. Everybody tries to use them for everything else, and I don't know how well that actually works. So that's just a couple thoughts on that. But as far as using logic chips, you can get I think like a 74 HCT will convert 5 volts in and put 3.3 volts out and keep everybody happy. And I think one of the like 74, is it 74 LS? Like 74 LS might work also. So go in the one direction, you can just put a logic chip in there to do that. And then go in the other direction, you can get something called, I think it's 74 LVC type parts. And it will, I think you run the thing on. No, I take it back. Those first chips I was talking about, they will convert 3.3 up to 5 volts. So if you need to go that way, and most of the stuff you have that has a 5-volt input, usually you can put 3.3 volt logic in and it'll be happy anyway. And right. So I'd say run it that way unless it gives you a problem. And then go in the other direction, you get the I think it's the 74 LVC parts, and you run the chip on 3.3 volts, and it will let you put 5 volts into the input on it. So it'll do the level translation. And that way you don't have all these weird, cute little MOSFET circuits that somebody designed in their basement. It's going to be a high speed circuit, and they're designed to do that kind of thing so that you can just get any chip of that logic family and stick on there. So if get something like, say, a hex inverter, if you don't want an inverter, you can probably find a hex buffer, or any, say, just AND gates, and just wire the pins so they work. And that's another way to do that.
Okay, I'll be right back.
Okay.
I will check on the motor controller ground for the motor ground and make sure that that's going through the way it should. Otherwise, I'm not sure how I'll try and address it. I mean, I've already put the caps on the two, so if there's a slight glitch, it shouldn't be dropping it out.
Yeah, as far as your processor reset problem, you could try swapping the motor, swap the two motor, physically swap the motors on the motor controller. So so if there's something funny about a motor, that should move it to the other
Yeah,
the other
hadn't
channel.
thought about that.
Just that'd be some way to eliminate all this stuff. Just figure out, one at a time, figure out what you can do to make that happen.
Okay.
I guess at this point you don't really know. Is it? I guess we're gonna have to assume it's the motors that are causing the problem somehow. It could be you got something else just in your code that's doing something stupid to you also. But if it is the motors, then it's either the the physical driving of the motor itself, or it's your encoders coming back. So you could maybe, if you can think a quick way to isolate one or the other of those to know if it's say for instance, don't hook the encoders up and just write code to run the motor speed up and down and let that
I've
let that
tried
run for hours.
and I got the problem whether the encoder connect the wires to the encoders were connected or not.
Okay.
So I don't think it's the encoders, but didn't know if there was a quick fix or need to do more investigation, and that checking the ground and swapping the motor right for left sounds like a good plan.
You have the motor there handy to put on the camera?
Let's see. That's the setup. Getting to the motors is going to be difficult because I have to lift the whole robot up. But it's this motor and that motor. And this is the motor controller. This is the itsy bitsy. There's the level converter. My cable's going to the encoders. This is a 10 amp 5-volt connected to this battery. This is connected to this battery.
Well, it looks clean. I've never heard of one of those breadboards being bad, but I guess that's should be on a list of options too.
I'm kind of not worrying about the burnt breadboard at this point. It was might have been an errant wire. It happened once. It hasn't happened again. I didn't lose a processor, so
Yeah, that surprises me. You didn't release the magic smoke out of that microcontroller.
nor out of the level translator. So anyhow, I'll let someone else talk now.
I think we might be good for the day.
Yeah, I don't think I have anything else to talk about. So let me take a quick look around in my junk land here, and I don't see anything to inspire me. So I guess we're done. I guess I'll say we're officially done.